All right, hello everybody. My name is Mr. Yosef, and today we're going to do solving inequalities. So when we see this first question, I want you to notice that this is first of all a quadratic equation. So let's get everything on the same side first. So that means that we're going to subtract our 9. And then for now, we're not going to worry about the inequality sign. So we're going to do x squared plus 4x minus 5 equals 0. And this is your standard factoring problem. So this -5 is called your product. This 4 is your sum. So what two numbers multiply to -5 and add to 0? That will be a +5 and a -1. We set these both equal to 0. And we get our two values. So these two values are actually where our function intersects 9. So when our graph intersects the number 9, that means our graph changes behavior. So that's why we make a number line. So we're going to make a number line. We're going to write -infinity to -5, 1, and infinity. So these are called, so I want you to think about, so imagine you have a parabola, right? Which looks like this. And if you look at this problem, do you see how the y-intercept is 4? And then this right here is like y equals 9, where 9 is right here. And so what's happening is, this is -5, and this is 1. So what we're going to do is we're going to have to pick values in between each section and see where our original function, x squared plus 4x plus 4, is greater than 9. So if we look at the graph, I think it's kind of easy to see that from -infinity to -5, which would be like in this section right here, we can see that it's definitely above 9. But imagine you weren't able to graph this. What you have to do is you have to pick a value. So I'm going to pick like -6. So I'm going to plug in -6. And I'm going to check to see if it's greater than or equal to 9. So this is 36 minus 24 plus 4, which is 12 plus 4, which is 16. So that means that the region from -infinity to -5 will be greater than 9, because when I picked the value in between these two sections, we saw that it was bigger than 9. So -5, let's talk about -5 for a second. I want you to put a solid dot at -5 and 1. And there's one reason why we're doing this. Because -5 and 1 represents our points of intersection, we know that those values are at least greater than or equal to 9. So when it's greater than or equal to 9 and you have points of intersection, we're always going to have a solid dot, because those are the values where it equals 9. So let's say this question was greater than 9, we would have an open circle, because if it says greater than 9, these two values give us 9, but it's not greater than 9. So next we go between -5 and 1. So I'm going to pick an easy number, 0. So if I do 0 squared plus 4 times 0 plus 4, I'm going to check if it's greater than or equal to 9. This gives me 4. 4 is not equal or greater than 9. So I'm going to put a sad face there. And then I'm going to pick a number between 1 and infinity. Let me pick 2. And we're going to check to see if it's greater than or equal to 9. So 12 plus 4 is 16. So this section is good. So this region and this region are good. So we're going to write this in interval notation. So that means we're going to go from -infinity to -5 bracket, because -5 is included, union 1 to infinity, and that is your final answer. Once again, this graph here illustrates what I did, but remember, these are friendly. Like x squared plus 4x plus 4 was pretty easy for me to graph. and y equals 9 was easy to graph, but you're going to be expected to do this without graphing. I just did that picture to give you a visual. Let's move on to the next one. This one is set up for us already. So we just do x squared minus 3x minus 18 equals 0. What two numbers multiply to negative 18 and add to negative 3? Well, that's negative 6 and 3. So you got x equals 6 and x equals negative 3. We make a number line, negative infinity to negative 3, 6, infinity. One thing I want us to pay attention to is this problem says we want to find out where this function on the left is greater than 0. So I'm going to go ahead and put an open dot at negative 3 and 6, because remember, negative 3 and 6, when I substitute these numbers into the function, these are the values that are going to give me 0. 0 is not greater than 0, so I know not to include them. So what you would do at this point is you would pick a number between negative infinity and negative 3, let's say negative 4. And once again, you're going to check to see if it's greater than 0. So here we have 16 plus 12 minus 18, which once again, this is true. It's definitely greater. I don't care about the actual number. All I care about in this case is that it's greater than 0. So this section is good. Then between negative 3 and 6, I'm going to pick 0. And it's negative 18 greater than 0. Nope. And then I'm going to pick 7. So we got 49 minus 21 minus 18. Once again, 21 and 18 together, that's 39. So 49 minus 39 is still greater than 0. So this section works. So my final answer will be from negative infinity to negative 3, parentheses, 6 to infinity. And this is your final answer. What I also want you to notice about both of these examples, these were both quadratic, so pretty kind. So I know you guys want to get to some weird stuff, so let's do it. So these, everybody, are called rational functions. So you know they're rational because you have the x in the denominator. So we're going to have to treat these differently. So what we're going to do here is we're going to move everything to the same side. So you have all of this, and we're just going to subtract it to the other side. So we're going to have 2 over x plus 5 minus 1 over x minus 3. And we're going to ignore the inequality sign and just set it equal to 0. Your goal here is to make both of these have the same denominator. This one is different because, once again, we're dealing with a different type of function. So if you remember this from the past, I always tell people x plus 5 and x minus 3, those are package deals. So if we want to make the denominators the same here, you have to multiply them by each other. So I'm going to multiply this by x minus 3. And I'm going to multiply this by x plus 5. And what's going to happen here is the denominators are the same. So I'm going to copy that once. And then on the top, I'm just going to write this. And there's a reason why I didn't do the math already, is because I want to show you that this negative 1 is going to distribute. If you don't do this, it's going to mess up the whole problem. This negative sign is kind of closer to the 1 than my, the way that I wrote it. So if we evaluate this, everybody, you're going to get 2x minus 6 minus x minus 5, which is x minus 11. So you got x minus 11 over x plus 5 times x minus 3 equals 0. Actually. All right, I just want to make sure, everybody, that this step right here, I'm about to erase this. This step was just me simplifying the numerator. Once again, I did that a little quickly. Just double check your math because you work so hard, you don't want to make a mistake at this point. So I'm going to erase this so I can have more room. I'm going to move this up. And now let's get to the weird part. So if you remember your information about rational functions, everybody, these bottom terms right here, these are important because whatever x value makes them 0 will create an asymptote. So x equals -5 and x equals 3. These are our asymptotes. And the reason why these values are important is because when you're making a graph, the behavior of your graph changes at these points. So that's why we want to set these equal to 0 and solve for them, because these values affect when our graphs are greater than or smaller than a value. And then x minus 11 equals 0. This is where it intersects. So all three of these numbers will go on our number line, but they're going on our number line for similar reasons, because all three of these values affect the behavior of our graphs. But the bottom two are called our asymptotes, and the one in the numerator is where the graph intersects. So now we're going to make our number line with all three of these values. So this is -infinity, so -5, 3, 11, infinity. So we're going to do our number line a little differently this time. The first thing I want you to always do is when you see asymptotes, we're automatically going to make an open dot at those values, because if you have an asymptote, that makes your function undefined. So there's no way that's going to be included when we're doing our intervals. It will always be a parentheses. Second thing, if you want to determine whether or not 11, if it's an open dot or closed dot, you got to go up here. 11 is what makes both of these functions equal, and since this sign says greater than, we're not going to include 11 as well, because if it was greater than or equal to, then 11 would be included, but since it just said greater, we're going to have an open dot there. And then from here, we do the same thing. You pick a number between -infinity and -5, and you substitute it at the beginning. So here, if we do 2 over, I'm going to pick -6. We want to see if the function to the left is greater than the one to the right. So we're going to have -2. And then on this side, we're going to have 1 over -9. And is -9, is -2 greater than -1/9? The answer to that is no. Because would you rather be down $2 or down, I don't know, -1/9 of a dollar? So that's why this region fails, because -2 is not greater. So you keep picking numbers in between. So let's pick 0 next. So 2 over 0 plus 5, is that greater than 1 over 0 minus 3? So 2/5 is greater than -1/3. So this region works. Then pick a number between 3 and 11. I'm going to pick 4. So 2 over 4 plus 5. Is that greater than 1 over 4 minus 3? Is 2/9 bigger than 1? Nope. So that's going to be a sad face. And then you're going to pick 12. So 2 over 12 plus 5. Is that greater than 1 over 12 minus 3? So we got 2 over 19. Is that greater than 1 over 9? So in order to test this, some of you might think this is pretty close, right? So if you need to use a calculator, I mean, you could. But I think 2/19 will be bigger. So if I put this in my calculator, 2 divided by 19 is 0.105. 1 divided by 9 is 0.11. So that actually does not work. So that means that this is also false. Right? So once again, that's kind of weird, right? Because we saw, normally you'll see an alternating pattern. We're just going to double check our math real quick. When I plugged in 4 to the left side, that is definitely 2/9, and that's 1. 2/9 is not bigger than 1. And if I plug in 12, we got 2 over 19 and 1 over 9. and 2 over 19 definitely does not work. Just to double check it, let's pick a bigger number. So if I do 2 over 15 plus 5 this time, is that still bigger than 15 minus 3? So 2 over 20, is that greater than 1 over 12? So is 1/10 greater than 1/12? I believe that is true. So here, that makes me feel like there was a math mistake somewhere. So what I'm going to do actually is I'm going to go to beginning, and I'm going to check here and make sure if I did everything right. So this step over here, everybody. So this was 2x minus 6 minus x minus 5. So this was x minus 11. Yeah, so it's x equals 11. So let me see what happens at 12. That is... Oh. Dang it. I find it. I'm so sorry, everybody. So this is the frustrating part. You're probably looking like, okay, like you wanted to scratch this whole problem. And guess what? I found my mistake, everybody. 12 plus 5 is not 19. That is 17, everybody. So here, I'm going to erase this. 2 divided by 17 is actually, look at this, 0.117. So it is actually bigger than 0.11. So that means that this is actually greater than. So our final answer then should be from -5 to 3 union 11 to infinity. So I just had a feeling something went wrong, and this is going to happen all the time. You're going to look at this, and you're not going to be able to find your mistake, and just doing something simple as 12 plus 5 and writing 19 could just really mess up a problem, but we stayed calm and we fixed it. So once again, sorry for that. Let's move on to our last problem. So for our last problem, I hope you notice that everything is kind of already set up. Like there's nothing that we need to move to the left side. So what you need to do for this problem is you need to actually factor the top and the bottom. So when you see x squared plus 2x, that's going to be x parentheses x plus 2. And then on the bottom, when you see x squared minus 9, that's a difference of perfect squares. So that's x minus 3 and x plus 3. So what happens here is, once again, these two, we know are going to be our asymptotes. So if we set them equal to 0, you're going to get x equals 3 and x equals -3. So these are going to be on our number line. And then you're going to take both of these values, x equals 0 and x plus 2 equals 0. And these are, I should have labeled, our intersections. So we got x equals 0 and x equals -2. And now we can just make our number line. So once again, you notice this one, everything's already to the left side. There's a number there. So all you got to do is factor the top and the bottom to find all your intersections and asymptotes. So we're going to go from -infinity to -3, then to -2, then to 0, then to 3, then to infinity. So we got a lot going on here. So let's see if you remember my system of open dots versus shaded dots. So if we look at our asymptotes, we're automatically going to go to them and make an open dot, because those values will always be undefined. -2 and 0, do we see how it says less than or equal to 0? Since -2 and 0 are where the function equals 0, those are going to be shaded. And then from here, everybody, you're plugging in points. So let's hope I can do a better job of not messing up where they actually intersect. So the first one is between negative infinity and negative 3. So let's pick negative 4. So negative 4 squared plus 2 times negative 4 over negative 4 squared minus 9. Is this less than or equal to 0? So 16 minus 8 over 16 minus 9. This is 8 over 7, which is definitely not less than or equal to 0. So this will fail. Because remember at the beginning of the problem, we want our equation to be less than or equal to 0. All right, let's pick a number between negative 3 and negative 2. This is when it gets a little messy because you actually have to pick a fraction, right? So I would have picked negative 2.5. So I'm not going to do that math for you. So if you look at negative 3 and negative 2.5, I'm already going to tell you that it's going to work. So this is going to be a smiley face, but this would be one that you can put in your calculator. But I would have picked negative 2.5. Then between negative 2 and 0, I'm going to pick negative 1. This one is nice and easy to compute. We want to see if it's less than or equal to 0. So 1 minus 2 over 1 minus 9. This is negative 1 over negative 8, which is 1/8. 1/8 is not less than or equal to 0. So this will be frowny face. Then between 0 and 3, let's pick 1. I think you see there's a pattern going on here. I think this one is not going to work because the bottom is going to be negative. This one will work because the bottom will be negative. So 1 plus 2 is 3, but 1 minus 9 is negative 8. So negative 8 is indeed less than or equal to 0. So this works. And then our last one, let's pick 4, which we saw on the bottom one that 4 worked. Negative 4 worked, so, negative 4 did not work, sorry. So I'm guessing the same thing is going to happen here. So 16 plus 8 is 24. 16 minus 9 is 7. So this is not less than or equal to 0, so this fails. So now, if we look at our final answer, we have from negative 3 to 2, union 0 to 3. And that's your final answer. So remember, once again, I wish this process went smoother. In some of these places that took a little longer than I wanted. But this is actually how your homework is going to be. You're going to mess up, especially if you're not using a calculator. So I hope this video helps. Please come to class with questions.